Hello everyone, for this tutorial video I'd like to discuss spherical coordinates, which are coordinates that use a radius and 2 degrees rather than a radius, 1 degree and a height as their arguments. In particular, the convention for spherical coordinates is to define the distance or radius with the rho. State that the angle theta is the same as a 2D angle, so it is the angle measured relative to the x or y axis, and we have a second angle which we denote phi to distinguish it from the normal angle that is measured relative to z equals 0. When we produce a sketch of the situation, we see we have a right triangle on the flat surface and a second right triangle constituting the height, whose first leg is the height and whose second leg is, interestingly enough, the magnitude or hypotenuse of the flat triangle. We see, if we pay attention to the 3D triangle alone, that the height z must equal the magnitude times the cosine of the angle measured relative to the xy plane. And by similar reasoning, the 2D radius or magnitude is the 3D magnitude times the sine of the angle measured relative to the xy plane. But we see that theta, or the 2D degree, is still the same in spherical coordinates, so it does not get any special changes. If we want to go from spherical coordinates to rectangular coordinates, we would do this by using what we know from cylindrical coordinates, seeing that we remember that we have formulas for x and y in terms of the 2D angle, and we also have a formula for the 2D radius in terms of the 3D radius, so we substitute this in, and see that x must equal 3D radius times sine of angle measured relative to xy plane times cosine of 2D angle, and y is the same thing except sine of 2D angle instead, and z must equal 3D magnitude times cosine of angle measured relative to the xy plane. With all that out of the way, we can see that we can apply this in a couple of examples that give equations in spherical coordinates. As in, if we were told the 3D radius rho equals 5, we would get 3D radius squared equals 25, 3D radius squared also equals x squared plus y squared plus z squared by the Pythagorean theorem. So we see it is an equation for a sphere with a radius of 5. If we are given something like this, the angle measured relative to the xy plane is pi thirds. We see that unfortunately there is not a simple way to convert it into rectangular coordinates, so we will have to think cautiously about this. But we can see it is stating that no matter how much we rotate or how far away we are from the origin, the angle is always pi thirds. So when we stop to think about a function that satisfies this, we see that a cone satisfies this because all points on a cone are at a specific or fixed angle measured relative to the z-axis. If we are given instead that the 2D angle is a specific value of 2 pi thirds, we see again that it's not easy to convert into a rectangular form, but we see that a line or a linear function will give us a fixed angle measured relative to the origin in 2 dimensions. So in conclusion, we have a line that satisfies this angle. Now that we have figured out how spherical coordinates work, we can move on to the big part of Calculus 3, which is discussing how multivariable functions work, as well as their calculus techniques. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.